Good morning, Algebra 1. This is Monday, June 1st. We have 5 more days left of class. We're going to be on lesson 81, which is graphical solutions, inconsistent equations, and dependent equations. Okay, I'm going to probably do 2 videos for this, so make sure you watch both of them because they're going to be long, and I don't want to take up too much time erasing on the board and stuff. So anyway, the first part of it, we're going to be graphing these 2 lines right here. These are going to be 2 lines, and what we're trying to do is visually see a point where they intersect. Okay, now mind you, my graph here it's not totally consistent, so you can see my dots are off when I drew my line and they're not exactly straight, but by the time it's over you will understand how to graph these lines. Now on this one in particular, I'm on 81.1 in your book. They ask us to use the slope-intercept method of graphing a line. And if you remember, this is in lesson 75, the slope-intercept. The slope-intercept part of the line is right here. It's when you have y equals, mx plus b, okay? This is y equals and this is y equals. The slope-intercept right here is positive 1, okay? If you remember positive 1, this is where it intersects the y-axis. This is the y-axis right here. This is the x-axis right here. So this line right here will intersect right at the y-axis at positive 1, which is right there, right? This one right here intersects the y-axis at positive 4, so it's right there, okay? One's right there, one's right there. Okay, now we need to figure out which way the line is going, and that's done by using the slope. The slope of the line is whatever's in front of the x right here when it says y equals something x plus something, okay? The slope is right here, and we know that there's an imaginary 1 there, okay? Now it's also an imaginary positive 1. It doesn't say negative x, it says just there's nothing there, so it's a positive. So positive 1, and that's the slope of the line, okay? So we know it intercepted the y-axis right here. Well, the slope means that it's rise over run. So it's going to go up 1 and over 1. If the slope is 1, it goes up 1 and over 1, and it just keeps doing that. Up 1 and over 1. Up 1 and over 1. Up 1 and over 1, and it keeps going forever like that, and that's why this line is like that right there, okay? For this line right here, we know it intercepted the y-axis at 4, right here, right? And the slope of the line, the slope of the line is negative 2. Now, the slope of the line, that means it's going to be going downhill, okay? If it's positive 1, it's going uphill. If it's positive anything, it's going uphill, right, from left to right. If it's negative anything, it's going from left to right, downhill. So this is negative 2, rise over 1, run. If it's negative 2, it's negative 2 over 1, right? So that means it's going to be going down 2, right, down 2 over 1. It's going to go down 2 over 1, down 2 over 1. Down 2 over 1, okay? So that's the line. All I really need is 2 points to draw my line. So where do they intersect? Where do these lines cross, right? Well, my line is not the greatest line, but you can see that they will intersect at x equals 1, sort of, and y will equal 2. Okay, 1, 2, right? So they intersect right at this point right here, 1, 2, okay? So we can go back and check this, this work right here by substituting 1, 2 into these equations and see if they work out, okay? So if we substitute x equals, in this one right here, if x equals 1, y equals 2, that would mean 2 equals 1 plus 1. And yes, 2 equals 2. If we do it to this line right here, and we see we substitute in 1 and 2, that would mean y equals 2. Okay, so that means 2 equals negative 2 times what's x? 1 plus 4. Right? So does that work out? Does 2, what's negative 2 times 1? Negative 2 plus 4. That's going to equal 2. And yes, that equals 2. Okay? So that's how we did that one. That's 81.1. That's also a reminder of the slope intercept method of graphing a line. Okay? All right, so real quick, I have to draw another graph, and this one's going to be worse than the last one because I'm not taking my time, but that's all right. Okay, now moving on to graphing. Y equals x plus 2. Y equals x plus 2, and y equals x minus 1. Okay, now, number of different ways I can do it. What's my slope intercept for the first one up here? My slope intercept is 2. So that means my slope intercept is going to be right there because that's where it meets the y-axis at 2. My slope intercept right here is negative 1. It's right here, right? What is my slope? They're both 1. That means I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1, okay? So my line is like that. It's also going to do it for this line. Up 1 over 1. Up 1 over 1. You can see my graphing thing. Well, what is going to happen here, they're actually supposed to be 2 parallel lines. With my crummy graph, it would have gone across somewhere, but they are parallel lines, and this is called an inconsistent equation. An inconsistent equation, but it's very easily solved, okay? Now we also know solving our, actually I think I'm going to move to, so if the lines are parallel, they're going to be labeled as inconsistent equations because the lines never cross, okay? I'm going to make another video, and this one's going to be on the dependent equations. And I'll see you in a second. Don't forget to watch the other video.